right. Well, it's been a little while since I've had a microphone in my hand. Kind of forget how much I enjoy getting to own the room, have my own jokes, stare at people uncomfortably if they don't, laugh at those jokes. Just, it gets a little uncomfortable, and then you start to make it really uncomfortable, and you make some friends. Yeah. All right. Anyway, I suspect everyone's thinking, "Hey, where's the pizza?" Which is kind of what I'm thinking. I will not be offended when it shows up and folks slip out for we may even have to have a pizza break just with how cozy it is in here. So there's water, and thanks to Bill and Bruce, the Pivotal team, there's some beer and water as well. This is the first time that we're meeting as Cloud Native Austin. We used to meet as Microservices and Containers Austin. And we did that because, because the container orchestration wars were happening at the time. And for as much as I love Docker, there was some natural tension between Docker subjects and other subjects. And that isn't the case anymore. And so I'm very happy to say that both the organizing that happens at Docker Austin and the organizing that happens here is done in partnership, which is fantastic. So this is a CNCF-sponsored meetup. And if you're not familiar with Docker Austin, which there's some familiar faces in here for sure, you should get familiar with it, particularly if you're coming from up north. They tend to meet up at Rackspace. So. All right, so I had hoped for, so this is kind of what happens when you announce a meetup with about 7 days until you meet. Turns out, without sponsorship and without other folks to give talks, you end up with one talk. I had hoped for a second talk. There's a good friend of mine, Ed Warnicle, here in town, a distinguished engineer at Cisco. He and some others are behind a service mesh. Actually, a bit tongue-in-cheek, the fact that that's named Network Service Mesh, because they will be the first to tell you that it's not a service mesh. And then that gets really confusing. And so I'd hope that maybe he could just do a lightning talk, but we've all got KubeCon coming up next week. Anybody headed out to beautiful San Diego? Very good. Oh, yes. Okay. Very good. Well, there's NSMCon, and so I'll be there speaking, and actually so will Ed. So, so for those that are going, you know which talk to skip, but you should see Ed's. It will be deep. Since we haven't met for about 18 months, just a quick note on who we are and why we meet. There's any number of reasons. Part of it's just selfishly for me to learn from each of you. Both as you go to learn and you ask tough questions and I fail to answer them, that makes me learn as well. And so while I'm here being the steward of the meetup, it doesn't mean that I necessarily control the agenda or the sponsors or those that want to come and talk. Meetups are mostly a really warm and welcoming place to spend some time up on the stage. So if that's you, whether you'd like to speak or you'd like to sponsor, there are submission forms for that, or just ping me directly. Our hope continues to be, and I think we delivered on this in the past, is to be a vendor-neutral place that hopefully fosters community. So certainly an open source centric set of topics that we'll have. As a matter of fact, speaking of topics, we'll make, I think, a couple of deals tonight. One of those deals is that we'll likely find some consistent subject matter on service meshes. There are a few different reasons for that. Probably the most prominent of which is that, I may be wrong, but it's my belief that service meshes are really about this third next step that organizations and individuals take in their cloud native journey, and it's a big old deal. And depending upon which service mesh you're picking up, there's a whole lot to it. or some of them are pretty small and they're relatively easy to get into, but there's a spectrum. And I wanted to show a spectrum of that tonight. I may have to tease you on that, but we are going to talk about different ones. So in the past, we've had some sponsors. Yep. So one of my few animations, but if you'd like to sponsor, go ahead. If you don't, we're going to host them anyway. You just may not have as much beer. That is an old slide. One of the things that I like to do, and it's not that much different from other meetups here in Austin, is, or maybe around the world, is to just engage with you a little bit. And I talked about an upcoming event, KubeCon. I asked who's going. We've got DockerCon coming back to Austin at some point. And so we'll talk more about that in the future, no doubt. But a couple of questions I'd like to ask is whether or not anyone is out there hiring, looking for a role. Anyone have something they thought was particularly nerdy recently that excited them? Got their little inner geek, just sort of giggly and bubbly? Anybody want to share something? Who's got to share? Uh-huh. Mm-hmm. Very good. Yes, ma'am.
DevSecOps Days Austin, the first DevSecOps Days Austin will be at Norris Conference Center.
The first DevSecOps Days Austin will be at Norris Conference Center on December 16th.
That's right. Brought to you by the same charming and lovely set of volunteers that brings us, or has brought us, Container Days, has brought us DevOps Days, I suspect. Talking, right, DevOps Days? All right, DevOps Days, awesome. Okay. Last chance. Okay. All right. Good. Let's get meshy. If you're a tweeter, this is the hashtag that we used to use. I'm almost embarrassed to say, go look that one up. I'm not quite sure what you'll find. Probably not much. Probably a fatter version of me, which doesn't usually happen. It's usually just the other way. Usually just getting bigger over time. Okay. Enough about my weight. Okay, so to the extent that we end up talking about or having some consistent agenda that does have something to do with service meshes, there's a lot to talk about with these. So one of the deals that I'm making is that we're going to talk about these, hopefully on a monthly basis, but that we won't talk about this. There are tons of other topics in the cloud native ecosystem and tons of other projects to dig into. And so we need to hear from those as well. If you enjoy what you see tonight, or if you like a slide that you didn't tweet out, go to the URL there, and you'll find this talk and many others. I'm a bit active in this ecosystem. I end up wearing a number of different hats, least of which is my full-time employer's hat. Those people. Point to the slide. Actually, all right. I think it's actually the width of the thing that's making me look like a balloon. So don't. Again, let's take our eyes off my weight. But calculatestudios.com. That is the URL where you can find this talk and others. So that's the thing. So there's another kind of deal that I wanted to make. Another really an experiment that I want to try. To be honest with you, I jumbled up all of my slides in just about an hour before coming up here. And that's because I wanted to try an experiment of presenting what a service mesh is not from the normal way in which I start. I want to see if this resonates with folks more than it usually does. On that, I expect, much like any of the technology meetups, that there's about half or more of us that are here exploring this topic for the first time. Show of hands, is that what's happening tonight? Do we have more than half of us who are kind of fresh on Service Mesh and looking for the, okay, very good. And then we've got some insiders in here who are gonna, they will smirk, you'll know when they smirk when they see the slide. Okay, so, a friend of mine, William Morgan of Buoyant, the team behind Linkerd, one of the service meshes out there. I think he'll readily agree with me that the concept that this slide conveys is arguably the most important piece of value that a service mesh delivers. It's this separation of teams. It's the ability for a dev and ops to iterate a bit more quickly. It is the notion that, well, let me present it to you this way. Let me say, in your environment, if you're running legacy, monolithic services or microservices, if you're operating long-lived processes, if you're running services, whether you're the developer, the operator, or any number of titles in between, or bookending those, like when one service goes to call the next, if that service whether that's your service or maybe it's an external service, maybe you're calling out to somewhere else, and that request fails. Question is, who's responsible? The developer, in this case, I'm going to pigeonhole it, the developer or the operator, whose responsibility is it for retrying that request when it fails? The dev? Who's responsible for ensuring that if requests are coming in, that there's a particular rate limit maybe in front of that service, so that service is maybe protected from from a bunch of things. Ops. This is good. You know what? This is great that this is a smaller deal. Please speak up. That's fantastic. You know what? Because I've asked that question on stage. I don't know how many times. Honestly, no one has ever actually answered, and I got 2 in the same night. This is great. I'm feeling pretty good. Yep. And so that's actually perfect. That's actually what I was hoping folks would say. Is that well, shit. I don't know. It depends on your organization. Depends on if they feel responsible or not. And some of these things I think do fall a bit more into ops land. And while others people can argue that they were taken care of in the app. And the deal is that service meshes help take some of those concerns I just mentioned too. But there are any number of resiliency, security, monitoring, observability concerns that you have when you're running a service. You can instrument your code to get some metrics out of it, to get some tracing out of it, to get some extra logs out of it so you can debug it. Or you can rely on the infrastructure to do a lot of that for you. Maybe not all of it, but a fair bit of it. Anybody use an APM or like an application performance management tool suite? Any vendors or tools out there that you care to mention? Okay, good. You guys all hate your APM vendors just like me. Okay, good. Well, good. Well, the bright news is there's a bunch of young startups out there who are kicking butt and taking names, overturning some of the oligarchs. That's nice. So my point to presenting this slide was to say, actually, outside of the hard technical details of what a service mesh is and does, this arguably is maybe the most important thing, is that there's no more diffusion of responsibility for, whoa, wait a second, I thought you were rate limiting that. Or I thought, yeah, hey, I set the retry twice, but turns out we needed to do it a third time. Or no, we needed to do it, wait a random amount of time and then try again. Or, okay, yeah, actually we figured out we do need to change that, but we need to roll a new version of your app because we're handling the retries in the app. Service mesh takes care of the things that I'm mentioning and a lot more, and makes your infrastructure a bit smarter. Makes it so that you can address those things that I just mentioned as configuration, declaratively. That both the operator, the developer, whatever hat you're wearing, you can see what that configuration is in your source code or in your source code management system. So, to me, that's the most important. And so, when you're running microservices, or when you're running monolithic services, when you're running anything long-lived, well, hell, if you're running event-driven things, functions, you probably need all these things. This all makes sense to me. I wouldn't want to be wearing the pager if we didn't have all those things. So clearly, you need a service mesh. You probably got a lot of these things today. Service meshes don't give you all of these. They do give you all of these, depends on which one you pick. They don't give you everything that you're going to need in this regard, but they lay down as an additional layer that I think you're going to find really empowers those teams that we were just talking about. So what is a service mesh? Well, it's a dedicated layer for managing service-to-service communication. That's the definition, which probably doesn't really answer much, or that's a definition that most will use. Some have called it a microservices platform. I think that's partially true. Myself and a fellow Google, well, not a fellow Googler, but a colleague at Google calls it Ryan, he calls it a services first network. It's about bringing functionality that I keep wanting to say microservices. That's a lot of the context in which you'll find a service mesh operating. Service meshes aren't strictly for microservices. They bring a lot of value to monoliths as well, to things that are not containerized. We'll talk about that. It's a network that considers for the things that we just said, and I'm going to describe more of those. So this is kind of fun for me because, again, this is something of an experiment, the way in which these slides are presented. So I'm going to use a sample app. This particular sample app it comes from Istio. Istio is maybe one of the buzzier of the service meshes. It's a project that, for the most part, Google initiated and sort of pooped out, and so those things tend to get rubbed into shiny golden projects after a while, despite being sort of blobs of turds initially. It's a big old turd, though. I didn't realize we were going to go quite this deep on this analogy. I can say that as I wrote a book, a couple of books actually on this subject. So it comes with a sample app. This sample, so actually all of the service meshes that we are going to talk about tonight do come with their own sample apps so that you can deploy the mesh, deploy a sample app, understand what the mesh does, and as such, they're all designed to show off the features and functionality of the mesh. In this case, this sample app is written, it's 4 services, 4 microservices, each written in their own language. One of them has multiple versions. This is what it looks like if you deployed it on Kubernetes. This is what, this is why there's a, this is your brain on drugs somewhere in there, comment. But this is what it looks like if you deployed the app on Kubernetes and on Istio. You've got, in Istio's case, all of a sudden you've got a bunch of sidecar proxies. And specifically Envoy is the default kind of batteries included sidecar. Anymore, what happens is, if you can kind of tell the difference, what we've got happening is we've got client requests coming in from the left-hand side that are hitting our front interface, our product page. And the product page, it's a book catalog, so it's just calling out to get details, reviews and stars and ratings and things about the books. And so all the end users interface with the product catalog, that interface. And all these subsequent dependent calls get made. And the user traffic, the requests are being addressed directly to the applications, each of these 4 individual microservices. When you bring the app onto a service mesh, that's no longer the case. Actually, literally the traffic is, a data plane is laid down, and what comprises the data plane are these service proxies. So Envoy, if you're not familiar, maybe think Nginx, or think HA proxy, except much more small and much more small, and not necessarily more performant. That's arguable. My point is, the application traffic, as it gets addressed, it actually gets addressed to each of the proxies. The proxies insert as a transparent network proxy. So kind of interesting. They end up handling all the traffic in between the services, so they see all the traffic. They're capable of enforcing those retries that we were just talking about. They're capable of generating some metrics that we were talking about, logs and traces as well. They're capable of providing an identity to each of those services. Through that identity, in this case, a certificate is issued, and automatic mutual TLS can happen. Now you can have no longer a GUI center of your services where you've got where you've sort of terminated SSL on the outside of your cluster, on the edge of your infrastructure. Now Now you've got an automatic secure infrastructure happening, MTLS in between each one. Okay. So I guess to reinforce this, there's some high level, so not all service, I'm showing you some things and telling you some things that not all service meshes necessarily give you, and you don't necessarily need them all. You can imagine that the more powerful your mesh is, just sort of a natural, this isn't always the case, but it's something of a natural consequence that it's probably a little harder to understand what that more powerful capability is. It probably takes a bit more time to grok it and understand it and deploy it and love it and care and feed it. But most of them, and this is oftentimes what gets someone hooked on a service mesh, is this notion that if you're running a number of services, the more services you're running, arguably sometimes sort of the less you know about what the heck is happening inside your cluster. I'm speaking in context of container orchestrators and running services there, but again, we're going to have a number of discussions hopefully on this subject, and we'll talk about some unanswered things here. I'm hoping everyone gets an intro to this tonight. This is really, this is kind of what gets people hooked. They immediately get some visibility, the blinders come off, and they say, oh, these are my top level metrics. These are the requests per second that I'm getting on this endpoint. Okay, this is how many times the circuit is broken here because I laid down a circuit breaker, because I said, hey, there is a rate limit. If that rate limit gets hit, break this, service mesh, break that circuit. Yeah, interesting. So that's, it depends on who you are and where you're coming from. A lot of times people will say, I've heard a lot of financial institutions say, well, actually our number one reason, really the only thing that we want is that sort of security in the middle, the east-west MTLS that I was just talking about, that mutual authentication, that encryption. That's great. Others come for very fine-grained, kind of granular traffic control. The ability to crack, so a mesh, again, I'm speaking in generalities, has the ability to crack open your packets as they're flowing through and let you route them in various ways, and let you open up the HTTP header, see who's logged in, and maybe say, well, they didn't pay their bill, they're not getting access to this service. Or maybe they paid the bronze, they're on the bronze plan, we'll send them over to the slow servers. There's also, to the extent that you've got that much control, there's a bit of chaos engineering that can happen here, a bit of resiliency that you can build in. To the extent that you're building in circuit breaking and health checks, you can open up those circuits. I mean, you can go through and facilitate some exploration, some experimentation of, hey, what happens if this service goes off? And you can control that through the mesh in a much different way than you would normally do that through in the land of IaaS or in the land of Chaos Monkeys and the Simian Army. If anyone's familiar with that, most of you probably are. If you're like me, so this is that. So again, I'm kind of having fun because these are totally out of order. If you're like me, you like to, it's helpful to me when I'm learning something to compare this new piece of tech with something that I already understand, so that I've got a frame of reference and I can kind of do a comparison. And so part of that is in talking about client libraries. So earlier when I said, whose responsibility is it to define and enforce a rate limit or expose a metric or do these things that, well, some of you might have said, well, it's the developer's responsibility. As a matter of fact, the developers have had to take care of that responsibility so much for themselves that they've started to write these reusable libraries. So that they don't have to rewrite that stuff every time that they create a new service. Moreover, they do so much of it that there are popular projects, popular frameworks that they'll leverage that are language specific, and they need to be language specific because it's really libraries that are tightly deployed, maybe somewhat tightly bound to your application. Your application is using these frameworks to say, hey, in code, I want 3 retries. The thing is with a service mesh, you don't need to have that infrastructure logic adjacent to your business logic, adjacent to your application logic. You can pull that out into a different layer. And so in many respects, the client-side libraries were kind of the first version of a service mesh, if you could you could maybe pick argument with me on that, but others haven't yet. The thing about this is there's some issues here. Yes, sir.
Can we ask questions?
Yeah, please. Yeah, do it.
So who's actually pulling that, like, that logic out? Is it the ops team that are actually injecting some of that logic in, or who's actually utilizing some of those, service mesh functionalities?
Yeah, it's a great question. So the question was like, hey, as this infrastructure control, infrastructure logic gets pulled out of your application, which teams do you generally find are being responsible for running a service mesh, maybe configuring it? It's the majority of the time you'll find that a service mesh is treated as infrastructure and as such is provided sort of as a cluster capability, as a service by the ops team. It's sort of now whether that was brought up as a need by the developers that said, hey, we're not going to write this stuff in anymore. We need to expect more from the infrastructure. You need to lay down a service mesh. You need to. The operators, I think, I would hope feel greatly empowered from where they were previously. If they're seeing that there's a bunch of disconnects between one service and the next, and they need to tweak how many retries happen, or if they need to lay down some of that security between the services, they're empowered to do so because that's just infrastructure that they can tune. If they wanted more metrics or a higher volume of logs coming out, of certain types of logs coming out, they can go tune that. So the short answer is probably like operators feel rather DevOps.
Thanks.
Yes, sir.
Is this a replacement for my API gateway?
Yeah, that's a great question. I think that's on the next slide. Yeah, yeah. So some of the issues here with this, though, are it's hard to get that logic right. It's hard to do building service discovery and circuit breaking, retry, retry budgets and other things. It's hard to, so even if you do, if you end up using more than one language, well, you're going to need probably more than one framework, and they're not going to uniformly, provide the same functionality. Even if you're using all the same language, you might have different versions of that library over time. And so in order to maintain consistency, uniform observability, uniform security, and kind of run your infrastructure uniformly, you're going to have to ask a lot of whether you're asking it of developers or not, you're going to have to roll the next version of your app to get to these things. Instead of doing that, you can pull it out and down into the mesh. So it's not the next slide, I think it's the next one. But some of you might be thinking, well, hey, I've seen service discovery before. I've seen some of these things, observability and logs and metrics and things like. I get some of that out of my orchestrator today or out of other systems today. Yep, yeah, that's true. The thing is, and I've given more talks on this than anyone should, but the thing is container orchestrators, when they came out, they really had to focus on lower layer concerns. A bit tongue-in-cheek, but I would say sort of layer 4 and below. Clearly, there are some, technically layer 7 things that are happening that the container orchestrator is taking care of. Point being is that they've got to pay attention to cluster management, to forming clusters, letting nodes, admitting nodes, scheduling containers, bin packing, blah, 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 the service discovery, the list goes on. And so there are network services. There is some amount of instrumentation that happens within your clusters, but not nearly to the degree, not nearly for services and applications themselves specifically. Service mesh comes in, lays down at a little bit of a higher layer. So anyway, I'll skip that joke. All right, so also you could be saying, well, hey, that's why I have an API gateway. Well, and moreover, like, what's the difference between a service mesh and an API gateway? It's the broad stroke here is that you'll most commonly find, there's two broad strokes. One, API gateways are having something of an identity crisis in the face of service meshes. As service meshes take foothold, so do API gateways start to feel a bit uncomfortable in their shoes, I think, and not that they would necessarily go away, and they won't. Many of us are very painfully aware of just how long technology sticks around and how long it can take to move off of technology. So The other broad stroke is that you'll often find API gateways deployed on the edge of your cluster or on the edge of your services. They're dealing a bit more with what you might refer to as north-south traffic, kind of out there on the edge, helping maybe do some SSL offloading, doing a number of API-specific things, redirecting some path-based things, hooking in with authentication systems, etc. Lots of good stuff. Once you make it through there, and you've got a litany of services that might be implicated in a given call, well, unless you go out and deploy an API, or the API gateway wasn't necessarily built to be deployed in between each and every one of those to make your infrastructure very resilient and highly resilient, and to do some of these other use cases. And so that broad stroke is API gateways were built with use cases of north-south traffic in mind, external to cluster traffic in mind. Service meshes were built with sort of internal to cluster traffic in mind. That doesn't mean that the two aren't going to overlap and that they aren't going to, have a. The other thing that confuses, I think, this question is that, so to the extent that those API gateways are having something of an identity crisis, they're leveraging some of the same tech that you'll find inside of a service mesh. And some of the tech that actually some meshes started out with and maybe kicked to the curb. I won't name them unless someone grabs me a beer and then I'll name them. But yeah, this is what gets it a bit confusing as well. So some of the API gateways like to call themselves a microservices API gateway. The way that they differentiate is that they're generally more developer-friendly in terms of their configuration. They're also container orchestrator aware. Okay. So I've talked about some of these before about why to use a service mesh. So you can eliminate your bloated application code, pull a lot of that infrastructure resiliency and security and other logic out of your application. You can provide consistency across all those services. So if you're saying, hey, I've got a cancellation that I want to have go in effect either at a certain rate or if, and it can be defined on external factors. Maybe it's, again, someone didn't pay their bill. And so you want to stop that traffic based on information that you would find inside the packet. You could, the service mesh can open it up and stop that. And the way that you configure that and the way that you achieve that is just through configuration of the mesh. Anyway, we talked about the diffusion of, avoiding that diffusion of responsibility. In certain environments, some of you, when I was asking those questions earlier, you might have been shrugging your shoulders saying, well, I'm not sure who's responsible for defining the rate limit. Like, when we hit a hard time, we just scale it. Isn't that what auto scaling is for? Or no? Okay. Lastly, we'll talk about this more later. But service meshes aren't relegated to the land of containers and microservices. Certainly, they can help with. I always have trouble choosing the polite word here for older services. Service meshes can most certainly help modernize them in a few different ways. Not all service meshes work outside of a container orchestrator. Some don't. Some only live inside of kubeland. Others are deployable on VMs and bare metal. Okay, there was a couple of things that I thought about just before coming here. One is that I don't have a demo tonight. I'm actually intentionally withholding the demo as a teaser for you guys to come back next time. And so I feel bad because it's a bunch of my voice for a long time, so if there are other questions, interrupt. Part of the reason that I reflect here is because I just enjoy looking at that slide. I mean, who doesn't? But yes, sir. Did you? Right. Yeah, great question. Let me paraphrase it. Maybe get it wrong. And that is that one of the things that I mentioned a couple of times is that service meshes can help with retrying or a failed request. And that, okay, good. Although maybe in my environment, I've configured a timeout for how long I'm going to wait to receive that request, or maybe on the client, whether it's on the client side or generally on the client side, you'd be saying, hey, look, after a certain amount of time, I'm going to walk, I think there's a bunch of different scenarios. Either the client is going to walk away or close the connection, or maybe one was established, but the response is taking too long to come back. And so whether you're timing it out or the infrastructure itself is timing it out, that, well, hey, how does the service mesh help in this regard? Like, that's going to happen any which way. Maybe,
I get it, you might have to go to a client and if it's not really long, allow the service mesh does the thing with time. But then I'm still having a lot of time.
right, yep. And so the client in this case is like, is it another service, or is it or would you consider it to be a user in a web browser or something?
No, not even.
Okay. So
I'm calling from my applications that are in this deal or whatever. So, and I would go with all of the service.
oh, okay. Which may or may not be on, which in this case is like off the mesh, maybe?
Software mesh.
Okay, very good. Yeah, so very good. Sorry. I got excited. So to restate the question, hey, maybe I'm running some services on a service mesh, and like in every, almost not every environment, but in many environments, there's going to be other dependent services that I don't know. Maybe I need to pull down refresh my static website that's running in a container here. I need to pull some code from GitHub, or whatever. And turns out GitHub's having a bad day. Those poor guys. And they're not responding quickly, or whatever the case is. Well, yeah. So hey, look, Salesforce went down. Oh my God, the sales guys are. Anyway, Twitter is not available. Twitter's rate limiting you, and your application is sitting there suffering, wasting cycles, kind of waiting on the connection to come back, waiting on a response, and it ain't going to happen. The deal is, in this case, the service mesh can help you figure that out maybe more quickly, for you to be able to say, look, in that case, to say only wait a certain amount of time. After that amount of time has passed, time out the connection and move on. Like either, move on meaning like retry a different, or not. I'm sorry, not retry, but try if there's a different path to go, or which is one scenario. So your service doesn't sit there. Your application doesn't sit there hanging up on something that's just not going to return. Like, because the service mesh can't help the fact that GitHub is just down, but it can help the fact that you're not sitting there, that you've got granular control and a bit of instrumentation under understanding in not waiting for 5 minutes or 10 minutes and changing that with ease, that configuration. I think maybe one other example, if we were to say, hey, there's a user out here, they're calling into your service is having a hard time responding. This user's on a web page, they're bringing up your .com site or what have you. The response isn't coming back very quickly. Maybe there's a couple of steps that happen in here. If the mesh will see that connection initiated, was created, and it can be watching for the response back. If it doesn't see it in a certain amount of time, rather than the user's browser timing out, it can say, look, excuse me, our users aren't going to wait past 6 seconds anyway. And if they have to, I just want to send them a quick message back that says, that redirects them somewhere else, that sends a redirect to their browser, or shows them a different message while they're waiting, plays them a video or something else, that the mesh can say that connection's been established, too much time has passed, I'll take action on that, outside of logic that you might have inside of your app to do that. So I think there's kind of trying to replay it from two use cases. One is someone is dependent upon you and apps that you're running on a service mesh, and the other one is you're dependent upon services external to the mesh. And in either scenario, how can the mesh help in that regard? Like, it's very painful. What's worse to a user hitting a website and getting back an immediate response that says, we're sorry, we're down at the moment, or something else? Oh, okay, yeah, very good, yeah. Okay, so time check. Did everyone get pizza? I think I said we would take a break, and I don't know that everyone did. Who's in for intermission? Like, who's in for a pizza? All right, good. And a beer? All right. Okay, good. Let's take a 5. I hope everyone is paying attention because there's 3 books to give away tonight. And so whoever can answer a question that I make up later will be the beneficiaries.
We can build networks for so much less operating systems. And I think they mentioned specifically cloud native. Cloud native. You have to talk about it. You have to talk about it. I mean, seriously, because the other thing too that people don't realize is many other applications that these networks can run. They could be running drone networks, autonomous vehicle, cars. It's not real. It's so far away. The word is there, but the frequencies that they're trying to use are 5G and other frequencies for distance and no, but I think first of all, I want to know what someone's going to be doing if they're walking down the street doing a gigabit per second. I don't know what that is. I don't know, but people would have oh, I think security should do that. Yeah. He's going to open it up and say, you know what, and he's going to tell about it. And I've been working on this multi-access HTTP, so putting servers closer to the edge, and those edge devices are connected to wireless spectrum. Could be Wi-Fi 6, could be CBRS, could be walking down 6th Street and pull a gun, well, you're allowed to carry a gun, but if you pull it, that creates an alert on the cameras so that when the network goes, you know, it's AI, it's huge. So a second later, hey, right here, someone just pulled a gun, there's a police officer right there. Now you gotta get that message to a police officer that's within range of that cell tower or that mini base station. So many different use cases, and then these are real. Like AI is coming around. Now we got to build the networks to do this, and you know, I'm, you know, these big carriers with all these mergers, T-Mobile, Sprint, and Dish is trying to start from scratch. And President and the Titanic, they don't know where they're going, and if they hit something, they won't even, you know. So anyway, it's exciting times, and I did not realize this was the technology that was behind it. So I'm glad I did. Yeah. Like, you know, I'll never be able to figure out how to do it, but I just need to understand it. Because the architecture of telecom is mesh networks. Our networks are fiber and it's wireless. And you know, they route mesh. Nothing to mesh. You know, the route goes down, the traffic automatically OSPF routes. I mean, these are all just fundamentals. But now you've got another layer. So now, do you work with T-Mobile? No. Accenture or one of their consultants? Yeah, one of the Fix company.
All right. Well, I tell you what, after about 12 ounces, the jokes just get funnier. So, yeah, that's nice. Thanks for laughing. My wife really, she does. It's not. I'm not sure why we're. Yeah. I did have a request from the audience, though. There's a point of curiosity about which of us identify if. Let's say that we've got to live in 3 buckets. That would be dev, sec, and ops. By show of hands, who categorized themselves in the dev bucket? Very good. And then in the sec bucket, I know Mr. KSI is going to be in the sec bucket. Very good. And in the ops bucket, awesome. Very good. All right, so I tend to get a bit long-winded. I realize that. I'm going to try to be a bit more concise and move through some material. There's also some interesting things, I think. It's funny, as I say that, there's some interesting things that people probably want to sit on the slides. But before I move on, let me lighten my load here and say, is anybody interested in a? It's not signed because that doesn't make it worth anymore. But if you are. Random question. So you may or may not know this, and it kind of depends upon how you classify what a service mesh is, what constitutes a service mesh. You easily say that there are 20 service meshes out there, 20 products, 20 projects that identify as being a service mesh. For the book, if you can name 4 products or projects, raise your hand and you'll get the book. Yes, sir. Oh, wow. All right. Oh, yeah. That was, all right, yeah. We're going to up the ante next time. Okay. Very good. Oh, Bruce. Very good. Okay. Let's talk. Let's actually get a bit pedantic. Maybe let's talk about what it is that does constitute a service mesh. Again, most of these are my opinions, but I've either stood on stage or written enough about it that people are starting to stop. They're not disagreeing as frequently. In my mind, there's about 3 layers of architecture that you will find commonplace in service mesh land. 2 very specifically. And depending upon if you've got a heritage as a network engineer, or maybe you've been playing around with container orchestrators, or things that have a control plane and a data plane. We're going to talk about planes, but not that kind. So there's a data plane here. We talked about the data plane a little bit earlier. This is where the heavy lifting gets done inside of a service mesh. This is where all of your service proxies come together, handle in line all of the traffic in and out of your services, in and out of your applications. This is where the kind of the raw processing happens, and it needs to happen quickly because this stuff happens in real time as packets fly by. The next layer here is your control plane. You'll find, and this actually is where I would stand firm and say that if it ain't got a service mesh, or I'm sorry, if it ain't got a control plane, then it's not a service mesh. If you're missing a control plane, then it's probably the thing that kind of turns you into a service mesh. So Kong was called out earlier. Who can blame them? But they were certainly rubbing the service mesh word up against them pretty early, and so was Console. I have friends at both of these companies that participate with me in some open source projects, and so I'm at liberty to say, and I would say it if they were here, that that I wouldn't blame them, but they previously probably weren't really a service mesh. I think they are now, both Console Connect and Kuma specifically. Okay, so the control plane is where you as an operator probably go over and affect policy. You decide how it is that you want for the mesh to work, or you as a developer. This is also this is the brains, the bits that tell these proxies what to do, what traffic to allow through, what not to, what to secure, how many metrics to expose, where to go check maybe, what other control systems or authentication systems that are maybe separate from the mesh to go and check and make sure that this request is authorized. And that authorization could come in the form of a bunch of different things. I threw out some earlier about whether or not that user is on the bronze plan, whether or not they've, the automatic accounting that will happen within a mesh, whether or not that user has gone past their plan. Now, the mesh isn't going to necessarily keep track of all of that, but it can certainly account for all the packets, all of the API resources that are used, and make that a quick lookup. So to give an example. So the control plane. The last one, lesser spoken about, but again, if you've got network engineering in your background, a management plane is probably not a new term. And here is where some, I think, would scratch their head saying, well, what's the difference between a management plane and a control plane? Management plane is probably a layer by which you begin to maybe federate heterogeneous meshes. You get large enough environments, you get early adopters, one group has adopted one mesh, the other one's adopted a different mesh. Maybe they come together, maybe they don't, maybe you've got mergers of things. Maybe you say, look, we intentionally are deploying two different types of meshes because one of them provides us this, the other one provides us this. We're okay with that. That management plane can help bridge those, can help federate services between them. A management plane can, we'll do a number of things. We'll talk more. So Istio, I'd said kind of the buzziest of them. Also, Istio is the biggest of them. I'll also challenge you this. As you're grokking and digesting what a service mesh is, I'll posit this. Prove me wrong. Two things. Istio has more lines of code than Kubernetes. I'm saying it does. Prove me wrong. Istio has more constructs, more logical nouns to learn than Kubernetes. Good. All right. Well, since I have the mic, that's how it's going to be. That's how that is. But please, I think it's a good. Well, first of all, it sort of blows your hair back maybe a bit if you've been playing with Kubernetes and you finally wrapped your arms all the way around it and you say, well, geez. But it's also hopefully an interesting challenge for you as you go home and study some things. Here's what the data plane in Istio looks like. So Istio is one of the meshes that helped popularize this type of deployment model where you're sidecarring a service proxy next to your application container. It's a popular model. It's not the only model. There's trade-offs. We'll talk about those. The default, the battery included here is Envoy as that sidecar proxy. I've been working with some nice folks at Citrix who did something that I haven't seen for 18 months. Did something that I guess I'm a bit impressed with. And that is they displaced Envoy in Istio deployments. So they brought in their CPX. You can deploy Istio with CPX as a sidecar proxy. I hadn't seen that since the days of Engine Mesh, which was set down as a project about 18 months ago, which is a project I'd gone around talking about a fair bit. Come see me later if that's of interest. So here's another one, lesser known. And so as we're recording this, and if they ever see this, I'm sorry for that. But lesser known, it's a security-centric service mesh, Octarine. Octarine is, not a Greek word. Unlike Istio, which is a Greek word, of course, if it's in the Kubernetes land. Istio stands for, these things get kind of heavy in my backpack, so you're going to have to, all right. Well, as you Google that, I was standing up on stage, I think at KubeCon. Well, who can tell me what Istio means? That's right. I've got the microphone. I know more than you do. Well, it means, it's a Greek word for sail, like the physical sail. And I was, doing my thing, feeling, looking down my schnoz at people. And, someone from Greece was in the audience. And let me know how to actually pronounce that word, which is not Istio, and I shit if I know it. They had my hat handed to me on that one. Little bit different. Octarine. This Octarine will deploy in a couple of different models. This particular one is without Istio. It will deploy with Istio or without. In this case, what they're doing, they are using Envoy as their proxy. They have written their own control plane, which is proprietary. They have open sourced a couple of things as OctaGuard or OctaRails is what they call it, but they open sourced or converted, I think, a mod proxy or capability or part of mod proxy into an Envoy filter, so they're able to deploy there. We've got a couple of other capabilities. So, security-centric service mesh. What a great way to go. And just, I guess, as a disclaimer, I didn't think of it. I advised that startup, and so just disclaimer. I do think they're doing well. Linkerd. For those that have taken a look at Linkerd or Istio or some of the more, anybody have words that bubble to mind when they think of Linkerd? Maybe in contrast or in characterization to other meshes. So certainly, I think you could argue this is probably the second most popular by name and by deployment service mesh. This is, if Nicola will allow me, this is the Docker Swarm of service meshes, whereas Istio is the Kubernetes of service meshes. And by that, no positive or negative connotation assigned. All that I mean to say is Linkerd's got much of what you need, and it's relatively easier to get going with. At some point, you might need more, and so yeah, or not. All right, network service mesh. I'm gonna keep this one to myself. You guys are gonna have to come back. It's a different mesh. Like I said, there's about 20 or more of them, so there's quite a few. So as such, it's not just that there are different meshes and they do different things. There's different ways of laying them down. There's different deployment models. Istio, and for those that are lucky enough to get a copy of tonight's book, you'll note that you can consume Istio a la carte, or not all at once. You don't have to bite off the whole enchilada. You can most folks start with the gateway, the ingress gateway, a bit there. And then they move on from there. Or some just turn on observability. They don't turn on any controls about rerouting traffic or inspecting traffic. They don't turn on security. There's a little bit of overhead for the value that's derived from a mesh. I mean, if you're running security elsewhere, you're going to be burning CPU somewhere. Different deployment. It's funny, I didn't even see. I jumbled up the slides, didn't even realize this one was next. But so here's kind of the ingress use case. I think this was taken from the Weather Company, which is an IBM company. They'd spoken about this a couple of KubeCons ago. And how they were just using, really just that first bit. They were using Envoy, the Istio gateway, to do a number of things for them. You can imagine they're offering up temperatures and they get quite a few requests. So they were trying to handle that in a more intelligent way. And so the point of this slide is you don't have to bite off the whole thing. There's Linkerd version 1. For the most part, if we don't specify, we're talking about Linkerd version 2, which, speaking of Docker Swarm, and I don't know why I was glancing. Yeah, I know. Ladies and gentlemen, we have a Docker employee in the house, and more than that, Nicola has got an extraordinarily popular container network utility container, right, that comes with it's a Swiss Army knife of container tools. Really popular. Thanks for making me lose my train of thought there, Nicola. So I had said that Linkerd is a bit like the swarm of things. And why did I say that? How is that coming up? Anyway, the link. Is that at one point Swarm said, "Well, F it. We've got a code base that worked all right. It's time to reincarnate and build that right into the engine and kind of start with a new code base." And so did Linkerd. So Linkerd v2 is what's out there today. It's a totally new code base. Old code base written on the JVM. There's some Scala in there and some other things. As such, a bit of a heavyweight, really predicated upon the architecture that was used at Twitter, which is where those founders come from, the founders of Linkerd. They since then took a hard pivot and picked up Go and Rust. You'll find Rust is used in a couple of places throughout service meshes. Engine Mesh, the one I mentioned earlier, Rust is used. Anyway, point is their first architecture was one proxy per node, one proxy per VM, one proxy per server. What's old is new. This architecture is coming back in style. We'll talk about trade-offs and other things another time. I'm already. Speaking of, there's a free short book, a free report that is a great introduction for the 60-something% of you who are new to service meshes that you might want. It's at layer5.io/books. I think you have to give up your email address for it, but it's in a completely serious and unbiased way. It's a great introduction to this landscape, and it answers questions like, well, hey, I've got an API gateway. Well, why do I need this stuff? It also calls out a few different other models, other than the sidecar model and other than the node per proxy model that, that there are merits to. Okay, last set of topics here. I was going to ask for a book, like, if you could name the number of, who could guess that, whose guess came the closest in terms of the number of service meshes. And then I realized, well, shoot, I don't have them all. But there is a landscape out there that is collecting them and indexing them with a bunch of factoids that is really unopinionated at the moment, and as such, has yet to perturb anyone. We're going to change that soon and express a bunch of opinion all over this thing. About how these compare and contrast. And if I didn't have enough friends already, I will certainly have them then. But you might enjoy this. This is a bit of info about the different ones that are there. Okay, so to the extent that there are that many of them, there's also a couple of emerging specifications, open source specifications. The one on the left-hand side was announced this last KubeCon, so about 6 months ago in Barcelona. It's called Service Mesh Interface. The focus of this specification, this set of APIs, is to provide a uniform interface, a uniform API surface area that if you write to or you interface with, on the back end, the work will have been done for you to interface with different service meshes so that you're not having to write to each individual one if you're using different ones, or if you're a vendor or what have you. And so if you're familiar with CNI, Container Network Interface, or CSI, not to be confused with KSI. Or there's another I out there. I forget. CNI. Anyway, it's an abstraction layer across your meshes. And that was announced by the good folks at Microsoft and some others. There's a project that I steward in open source that announced a partnership with this SMI last KubeCon. I'll tell you about it in a second. Here, this last VMworld, well, a similar announcement was made from a different set of vendors. And it's called Multi-Vendor Service Mesh Interoperation, which kind of disappoints me because I was hoping they had originally called it Open Service Mesh Interoperation, so I was hoping for sort of an open SMI. Anyway, the other code name for it internally was Hamlet. VMware are by and large the stewards of this. They partnered with a couple of meshes, some of which have partnered with SMI, and most prominently others of which are not. Some of the vendors are at play here. These, in fact, on the surface are competing specs. And I know they don't sound important right now, but they could be rather important later. Maybe some of these are details that vendors are really interested in, but maybe not. Maybe as some of you go to hedge your bets on, well, which service mesh should I adopt and go forth with, maybe knowing that it is compatible with maybe you want to interface on a third-party layer, a vendor-neutral layer. So this second one called Hamlet, it is for purposes of defining an open specification to federate meshes. So not one to necessarily say, hey, I'd like to get metrics out of a mesh and make that same call across any of them, but rather this is to an east-west spec, if you will, to federate meshes and allow them to have a common language from which to exchange and announce services that are running on one, announce it to the other, and provide some interoperability between service meshes. So both of them are about interoperability, but from different vantage points. So I've been spending a fair bit of time with both of these teams. And 2 more slides, I think. It's an open source project that was, the genesis of which is for me having stood up on stage, talking about meshy things, and people saying generally 2 things, like almost universally. I think I've heard one of them tonight, but not the other just yet, and that is that by the time I'm about done speaking, not only are people running out the door, but they're also saying that, okay, hey, I get it, there's a lot of value here, so, hey, which one should I go with? What's the right one? And then, I tell them, and then since we're being recorded, I won't, no, and then, okay. And so it's one of those very frustrating, well, it depends. There are some easy answers, but generally it depends, and some of those questions aren't very tough to figure out. The second question that's pretty universally asked or pretty universally identified is, again, it starts with, well, thanks to your beautiful explanation, I get it, there's value here, I'm ready to adopt, but wait a second. All the packets are now going through this new proxy layer, they're being intercepted, and then you're generating things and you're burning CPU, you're using memory, you're injecting latency, right? Because this stuff isn't, hey, nothing's for free. What's going on here? So what's the overhead? Again, it depends. Yeah, I'll spare you some of the other rhetoric there. There's some recordings that where you'll see me drone on about some of this, where I think I'm being funny, and my wife tells me later, you're an idiot. So we went off, and I got tired of standing on stage saying, well, it depends, and so Envoy doesn't necessarily publish their stats, and kind of, rightfully so, because you could be running it in different ways, and neither did the other ones, and well, the thing is, it wouldn't really matter if one of them published their stats. You'd look at it and you go, oh, I'm never going to run into that. That's amazing. And you look at the other one, who ran a totally different set of tests. You go, that's amazing. Moreover, the way in which you visualize that blew me away. That's awesome. But so which one was fast? Well, I have no idea which one was faster, because you're running totally different applications on different infrastructure at different rates and blah blah. All of the, and so born out of frustration and not out of any affinity for performance engineering, I went off and helped create this open source project. This last summer, it was a Google Summer of Code project. So we've had some and continue to have some young folks who are helping us here. And so it set off with a mission to answer these 2 questions. Which service mesh should I use? And what's the catch? Nothing's for free. And so as such, it stands up. It conveniently provisions more types of service meshes than any other project in the world. Wow, that feels so good. But then more of these damn meshes keep coming out and making it harder to keep pace. So we're spitting out many new adapters. It also focuses on trying to answer that question of providing some convenient tooling to measure the overhead, and so that you can weigh the value of what you're giving and tweak some configuration knobs to say, give me more value, but you're going to, I'm going to pay for more overhead versus not. Moreover, to the extent possible, it provides an apples-to-apples comparison of performance across meshes. And I say that with a bit of reservation. So it's not apples to oranges per se, but it's sort of a red delicious to like a golden delicious or something. The meshes are not the same unto their own, so but it gets you in the ballpark and people feel comfortable enough. Since we've been, I figured we'd do one more slide, and that is, since we've been talking about architectures, here's the generic version of a service mesh: a control plane, a data plane. Not all of them look like that, but and then here's an example of a management plane laying down on top. This Meshery itself has a long-lived, or is mostly written in Go, runs and provides a web user interface, and has adapters to different service meshes. I think right now the number that we have, there are 5 stable adapters, and with more in the works. Some vendors, I mentioned Citrix earlier, creating them. So that's the architecture. These are the 5 that it has today. If you don't recognize, so Linkerd, Console, Istio, Octarine, Network Service Mesh. I'll let you go look up the other ones in the works. So we'll save this for another time, how it is that Meshery interfaces with these service mesh abstractions. And I'm realizing a bit late that like maybe we should have included a demo and it shouldn't have just been all talk. Come back next month, nothing but demos. Call me out, laugh at me, pull my shorts down if I do slides. All right. Who's got a good question to ask to give away a book? Oh, yes, sir. Oh, I bet you know the answer to it too.
I still don't know whether I should stick with my API gateway or set up both, or just teach the API gateway and move with partners.
I'll offer up a thought, and that is to keep the API gateway for now. That it would cause you more grief, I think, to get rid of it while you're also trying to learn service mesh and get comfortable and be proficient. That you think about it, if there's a universal data plane, or if we talked about a few different service proxies. We talked about Envoy a fair bit, and HA proxy, Nginx, Traffic, even though it looks like Traffic, it's Traffic. Ambassador is an API gateway, but if you look at some of the API gateways, you'll find that by statistical median, most of them or the majority of them are built on, the statistical median of them are built on Envoy. If you consider Envoy is pretty part and parcel also to that most of the meshes are built on Envoy. That part of that identity, like the core capability there being the same, that is it probably over time that these things get pretty well blended. And so the deal is that while the core tech is the same under the hood, what the value that's wrapped on top of it is either today optimized to be a microservices API gateway or to be a hardcore kind of transparent, not to be seen proxy. And so one of them is in service mesh land, the other one's in API gateway land. I think it's just a matter of time before that it answers itself. But for right now, like it's going to take service meshes a little while to have all of the full features of what you would get out of other API gateways. If that helps. Yes, sir. Yeah. Yeah, that's a great question. And so the question was, of all of the things that service meshes do, there's all kinds of things to measure the performance of. Some of that is, how in a large environment, if you've got 1,000 proxies in your data plane, it might actually take a while to push down configuration to all of them, or for all of them to reach up and grab it and pull it down. That's one thing to measure. Hey, how that proxy, as it's routing traffic, it may, depending upon what type of rule I've given it, that can have a greater impact versus not. And so there's a bunch of things to measure, and the question is, what is Meshery as an open source project measure in this regard. Today, most prominently in terms of performance, it measures, it measures latency of what it does to facilitate performance monitoring today is load generation of HTTP traffic, soon load generation of gRPC traffic, and we'll see if it doesn't generate a bunch of NATS messages at some point. Gives you some knobs over how much of that to create and how quickly. Measures the latency of responses that you get back from an endpoint. Measures the throughput by which you can, how many requests you can shove through this thing. It also measures then the memory and CPU of each of your nodes and of your control plane components, such that then you can watch the impact that different different ways in which you're configuring your mesh have. And of the things to measure that you had just prattled off, that I think that was like 2 of them, 2 of like 5 or 6, right? So it doesn't yet go into other areas that if you want to run some pristine infrastructure, so these are good. I'm writing those down. Yes, sir. It's a great question. The question is, hey, can you give a quick comparison between Istio and Linkerd? And I'll say this: to the extent that anything that I say right now makes sense, or if it does or doesn't, that's in part what Meshery is built to answer, is to help give you convenient tooling to let you do it yourself. But the quick characterization, the high level one, I would say, like, if you're familiar with Docker Swarm, let me say this: that Linkerd has been quickly catching up in capability to Istio. Like Docker, this is funny, the analogies that can be used here. Like Docker, it has been focused on user experience and time to value. Rather, like in about 90 seconds, you'll have value from deploying Linkerd, meaning that you can quickly onboard an application onto a Linkerd service mesh and see some top-level metrics, requests per second, and see it kind of broken down in a tabular format or in a visual format in their dashboard. They only recently added support for propagating distributed tracing headers. It's a smaller kind of single binary deployment. They use Rust as their data plane component and the Go for their control plane. Linkerd doesn't have, so when you describe all of the capabilities that are conceived today for a service mesh, that's Istio, and it kind of falls into 3 big buckets, kind of sort of observability and monitoring, traces, logs, metrics. Another one of being security around, Istio has a built-in certificate authority, and it issues certificates every single time a new service is provisioned on the mesh. That facilitates a couple of things: the authentication, that mutual TLS, the encryption. The third bucket being granular control, traffic control, and as such, you can use it to do a number of things. So, point being, in contrasting them, Linkerd doesn't have all of those or nearly as robustly. Linkerd is a bit like if you're familiar with HashiCorp's Nomad. It's a single binary that you deploy. It's pretty easy to just logically grok. And in terms of like size and footprint. Whereas when you lay down Istio, you'll get about 55 to 60 custom resource definition or custom resources in Kubernetes, which I'm hopeful that both of the projects will stay around, because there's a world of people who just needed a certain amount of functionality. And then there's another world of people who want to crack it open and configure it all any different way and deploy it a bunch of different ways. And so, kind of the contrasting. Istio probably has the highest proven scale at the moment in terms of like number of services that it's running. That I work with that team a fair bit. There's a lead in Google and one in IBM, and they're pushing the envelope and improving there. They improved a great deal with that regard post 1.0. So Istio is on 1.3.5 right now. yeah, that's the, I mean, you know, and so I don't characterize those as in, I try to do my best to characterize some of that in good lights, and some of that I'll let you leave to your imagination in terms of bad things. So yeah, so Istio's literally been paying a lot of attention to, as a matter of fact, I helped create the user experience working group in Istio to help pay attention to what Istio's Linkerd is getting right, and so there's, like we do in open source, there's some copying of, well, open source or not, there's some copying of ideas. So Linkerd is getting, I'm sorry, Istio is getting easier to use a bit. Linkerd is getting more capable. So. Well, other questions? Oh, maybe I should give away a book or something. Here's one thing. Do me a favor, go out and subscribe to the newsletter. There's some interesting tidbits out there. There's also a workshop that I'm considering hosting here to take people through Istio kind of Istio through and through. I won't say Istio the hard way. Probably soon there'll be a Linkerd one as well. It's a good repository. We created this this community, the service mesh community there, to be, it isn't yet, but ultimately to be the epitome of where you'd go for service mesh things. It's, if you're looking at it and thinking, oh, good God, that's ugly, that's by design at the moment, so don't hold it against me. Who just subscribed? There it is. Did you already get a book? No, okay, yeah, very good. Well, that was it, yeah. Okay, anybody else want to subscribe, or? Oh, yes, he does. KSI wants to subscribe. Does anybody know what KSI means? It's this guy made it up, and I thought that, no.
You know, everybody is familiar with KPI, key performance indicators. We created the word key security indicators. Path find request, session disconnect. A lot of times we are really looking at like more than what is happening in this other level, more than what's, so just the word KSI. Thank you.
That's pretty good. Yeah. I'll use it, and but I'll have to put the trademark next to. It's very kind of all of you to come out. Next time we'll announce maybe more than 7 days in advance. Maybe the pizza guy will be on time. That'll teach me to prepay the tip. Lesson learned for all of us. So we'll hopefully we'll meet again in a week. I'll be, I'm sorry, not a week, in a month or so. I'll be back from KubeCon. So will others of us. As a matter of fact, maybe that's a good call out for those that are going to head out for a week of sun and nerdery, that next time we meet, maybe you could bring back something that you saw and just kind of share with the group. Anything else? Who's sick of listening to my voice? Well, that's worth a book right there. That was funny. Oh. Oh, yeah, sure. Yeah.
Listening to you over the fan.
Yeah. Next time, maybe next time I'll bring that smaller guy. That smaller. It's easier on the backpack anyway. Thanks so much for coming, guys. Feel free to please remove. Please don't let me take all that beer home. So I'll stay married.